Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing on the transgressive systems tract, and in this lecture also we will continue that discussion on transgressive systems tract, and that will be the last part of this particular series on discussion on this transgressive systems tract. So, in the previous lecture we have already discussed about the different depositional aspects, the distribution of different depositional systems within the transgressive systems tract, and there we have already seen that during the transgressive systems tract we get deposition in the interfluvial and the coastal area, followed by the shore area, to some extent into the shallow marine area, and then in the deep marine part in the form of heeling phase deposits, and also the deep marine deposits in the form of low density turbidites and some mud flow deposits. So, in a nutshell, this is the overall depositional scenario during the transgressive systems tract. So, when we look into this kind of depositional pattern, this kind of distribution of different depositional systems within the transgressive systems tract, what you can observe is that there is an overall decreasing trend as we are moving through time, as we are starting from the early TST to the late TST. What you can observe that there is a decreasing trend in terms of the amount of sand that is being delivered into the deep water environment. So, in the early TST phase, we see that there is a low density turbidity current where we are getting sand, and the proportion of sand in those low density turbidity current, they are gradually decreasing. And finally, when we are reaching into the late phase of TST, then it is replaced by mud flow where the sand supply is almost nil. So, that gradual decrease in the supply of sand into the deep marine environment, that commonly is related to the landward shift of the shoreline, which is commonly associated with transgression, and that gradual retrogradation of the shoreline increases the distance between the river mouth and the self edge. As we already know that the sediments are distributed, sediments are dumped at the river mouth, and from there they are redistributed by waves and tides. So, since the distance between this river mouth area and the self edge is increasing gradually, so the supply of the coarser clastic, the supply of sand is gradually decreasing. Along with that, the more trapping of the riverborne sediment within the aggregating fluvial settings, within the aggregating shallow marine systems. This is another factor, because as the transgression is going on, gradually the system is onlapping back, and when it is onlapping, gradually the individual depositional systems, they are trying to trap the sediments, they are trying to capture the sediments in order to onlap. So, majority of the sediments are getting trapped, mostly the sand are trapped within the river part, as well as they are getting trapped within the shallow marine systems. So, the overall supply of or the availability of these riverborne relatively coarser sediments into this deep water part, it is gradually decreasing as the transgression is going on. And in addition to these two factors, the third one is the gradual decrease in the energy which we can record in terms of the change in the fluvial system. As the fluvial system is gradually aggregating, it is gradually onlapping back. So, there is a gradual decrease in the rate of denudation of the source areas as the gradient of the river is gradually decreasing. So, due to that gradual decrease in the river gradient, gradual decrease in the slope of the river profile, there is a gradual decrease in the denudation process which is going on in the source area. It is further aggravated, further increased by the coastal aggradation. That coastal aggradation also helps in the decreasing rate of erosion going on in the source area. So, these two factors together further decreases the supply of amount of riverborne sand to the deep water environment during the base level rise. So, when we look into these factors gradually starting from the early transgression, early phase of TST to the late phase of TST, what we can observe is there is a very gradual change in the sand is to mud ratio. That change can be observed in the deep marine part, that change can be observed in the self area into the self edge area. So, definitely when we get this kind of changeover, that will affect the distribution pattern of the sand mud ratio, and in turn that will affect the reservoir quality in terms of when we think about the distribution of the hydrocarbon bearing reservoir rocks. So, in this particular class we are going to discuss on that particular aspect regarding the economic potentiality in terms of the accumulation of different economic minerals or economic resources, for example hydrocarbon, coal or placer deposits. So, the preservation potential of these transgressive deposits, they are significantly high, particularly when we compare this with respect to the other packages which is forming during the other system strats. And this is applicable throughout the basin, starting from the deep basin part to the basin margin. And the main reason for this particular fact that the preservation potential of these transgressive deposits is high, this is just because these are overlain by the HST deposits, the high stand normal regressive deposits, which commonly leads to aggradation of the sediment packages across the entire basin. So, this particular phase, this high stand phase is not associated with erosion. This already we have discussed in our class on high stand system tract, and there we have seen this is entirely an aggradation and progradational package. So, when we have no chances of, no scope of erosion, then the preservation potentiality of these transgressive deposits that increases, that is high. So, when we compare that with respect to say FSST package in the self area, that is undergoing huge amount of erosion leading to subaerial unconformity. So, the preservation potential of FSST deposits are significantly low. When I compare that with respect to the LST deposits, low stand system structure deposits, they are also affected by wave ravagement erosions during the next phase of transgression. When the LST is going on, maybe there is not much erosion is going on, but after LST there is a transgressive phase, the TST, and already we have discussed that during TST we get wave ravagement. So, that wave ravagement directly overlying the LST can erode the earlier LST deposits, and the HST which is overlying the TST deposits, they can get eroded by the subsequent base level fall, and they can be overlain by the subaerial unconformity. So, the preservation potentiality of the HST deposits are also significantly low. So, that particular aspect, the preservation potential of the transgressive deposits is significantly high. That particular fact, that particular parameter is one of the key parameter in terms of accumulation of different resources, for example hydrocarbon and coal. So, if we talk about the occurrence of petroleum in terms of the chances of getting petroleum plays, then when you look into the landward part with respect to the shoreline, the potential for petroleum exploration within the TST, within the transgressive systems tract is relatively less, as there we commonly do not get extensive development of thick coarse grain sediments, extensive development of sandstone, and on the other hand we can often get development of or deposition of the fine grained floodplain facies, which intermittently truncate the coarse grained channel fill deposits. Since during the transgressive phase there is a rapid rate of base level rise which is leading to increasing accommodation, so that leads to frequent flooding. So, floodplain deposits, they are more frequent, they are more common, more abundant with respect to the channel fill deposits. That restricts the distribution of the channel fill deposits, which is commonly dominated by sand, and that restricts the chances of the petroleum play within the fluvial part that makes this fluvial petroleum play in terms of the hydrocarbon occurrences as a moderate to poor in terms of the generative condition in terms of its occurrence. So, the fluvial reservoirs, they are commonly represented by isolated channel fields. They are commonly represented by the levees associated with these channel fields, and associated with levees and channels very often we also get crevasses play deposits which are engulfed, which are covered within thick floodplain deposits, which are commonly the fine grained deposits, commonly the mud. So, within the fluvial system we do not expect very good quality or excellent quality reservoirs to form just because of the lateral limitations, the spatial limitations of the occurrences of the sand deposits, as they are very frequently covered by, engulfed by the mud deposits which are formed in the upper banks. If we look into the shoreline area, in the shoreline part, then from the seaward side of the shoreline commonly we get the onlapping hilling phase deposits. So, the shore hilling phase deposits, they commonly trap a major part of the sand which are supplied through the river, and then they are reworked by the wave refinement processes in the shore area and they get trapped over there. And the surplus of this sediment, surplus of this sand which are developed through this wave refinement process, they continue to supplied into, they continue to feed the deep water submarine fan through formation of successive low density turbidity currents. This happens during the early phase of TST, when the shoreline and all these processes like the supply of the riverborne sediment, they are reworking by the wave refinement process, all these processes are going on very near to the self edge area. So, in that kind of condition, we commonly expect that there will be significant amount of sand is getting deposited within the hilling phase deposits. There are significant amount of sand is supplied in the deep marine part through low density turbidity currents. During the early phase of the TST, we know that the first hilling phase deposits, they form along the continental slope where sediments are supplied by these wave refinement processes going on very near to the self edge on the self area. So, in that kind of scenario, that kind of condition, when the hilling phase deposits are forming along the continental slope and these hilling phase deposits are regularly affected by channels which are forming the low density turbidity currents, which are carrying these low density turbidity currents, they tend to entrench, they tend to make more erosion than sedimentation through these hilling phase deposits. This more erosion with respect to sedimentation, this is because of the underloaded nature of these low density turbidity currents, because in this kind of currents the amount of energy, the amount of transport capacity is more with respect to the sediment load available in that particular turbidity current, and that is moving down steeper slope. So, this kind of processes going on in the early phase of TST commonly do not allow formation of good reservoirs. So, during this early phase of TST along the continental slope where the hilling phase deposits are forming and they are very frequently affected by these low density turbidity currents, we do not expect formation of good reservoirs. So, during the early transgression where we can expect formation of petroleum plays, we can get them in two different regions. One towards the shore area, which we can call as the continental shelf area, where the shoreline is presently existing, presently standing at the early phase of TST. Just recall the depositional model that we discussed during the early phase of TST, where the shoreline started moving from the self edge delta that has formed at the end of the LST, and from there the shoreline is moving back, is retreating back. So, all the deposits which are forming, all the processes which are going on the self area, and from that self area gradually a wedge shaped prism is forming, which is the transgressive prism which is forming over there. And what is the character of that self-faced wedge? It is commonly associated with formation of either an estuary, formation of the shore area, and also the fluvial system. All these things are forming within the continental self area. And the second one is the deep water wedge, because during that phase, if I go beyond the slope area where these successive low density turbidity currents are developed and they are coming down the slope, and then they are reaching to the basin floor, where at this particular point the low density turbidity currents, they are getting splayed up, they are getting flared, and they are getting deposited in the form of fan. So, finally, in that area what we are getting is sand deposit through these low density turbidity currents which are carrying sand. So, the petroleum plays during the early transgressive phase, they are commonly associated, they commonly occur in these two areas broadly. However, if we look into the late phase of transgression, there we commonly get the concentration of the petroleum plays again within the fluvial system or in the shallow-marine depositional system, but now this shallow-marine depositional system has more landward, it has retreated back and leading to a more open continental shelf. So, though again in this case we can get a transgressive wedge, but the character of that particular transgressive wedge forming during the late phase of transgression is different from the transgressive wedge which is forming during the early phase of transgression. So, accordingly, the occurrence of petroleum plays, the occurrence of a hydrocarbon reservoir is changing from early phase of TST to the late phase of TST. So, during the late phase of transgression, commonly what we expect? We commonly expect the fluvial to shallow-marine depositional system as the most prone area for hydrocarbon reservoir. Now, within this fluvial to shallow-marine, we can expect the fluvial system, the inter-channel fill system. We can expect the coastal area which includes the estuary, which includes the shore area, and also the lower shore face area where sand is getting supplied through wave ravinement processes. So, in all these areas we can expect formation of petroleum reservoirs. So, apparently this looks very similar to the early phase of transgression, except the fact that this entire process is occurring, this entire formation of reservoir is taking place more towards the land with respect to what has happened during the early transgression. Now, within the sandy fluvial successions, within the sandy fluvial deposits, commonly we can get channel fills, we can get levees, we can get crevasses plays, and they are commonly engulfed with floodplain fines, overbank deposits, and they can act as good sill rock for these sand bodies, these channel fill sand bodies. We can also expect formation of this kind of reservoirs in the backstepping beaches, where we get successive stacking of sand which are coming into the beach area. We can get good quality sand deposits which can act as a reservoir in the bayhead deltas which are occurring along with a transgressive coast or maybe within an estuary, and we can also get estuary mouth complexes where we get plenty of sand supplied, plenty of sand captured and deposited, and that can also act as good reservoir. Apart from this, in the shore face area during this late phase of transgression, we expect heeling phase deposits, and those heeling phase deposits can be sand rich and they can act as good reservoir for petroleum. Also, we can get prograding deltas, where this kind of prograding delta can form, that we have already discussed in our previous lectures. So, when this kind of prograding deltas are forming within a transgressive coast, we can expect formation of good reservoirs, because deltas will be carrying sand into the mouthbar area. And finally, a major one is the self sand macroforms. As we have discussed in the previous lecture, about the different macroforms that form in the self area during the late phase of transgression, like the sand ridge, like the sand ribbon, like the sand sheet. So, those sand deposits can be a good reservoir in the self area that can form during the late phase of transgression. So, there are so many possibilities during the transgression phase. Now, if we look into these self sand deposits, these macroforms, they are commonly formed as a result of erosion and subsequent reworking of the sand prone deltaic or coastal plain deposits, and commonly they are reworked by wave processes, maybe storms, and very often the self tidal currents. How they form, that we have already discussed in our previous lecture, so I am not going into that part. But whenever we get that kind of sand deposits which are forming in terms of very large regional scale structures, very prone with deposition of sand, they can act as good reservoir. These deposits, these self macroforms, they have significant exploration potential because commonly they are sand prone, and more importantly they can be get encased, they can be get covered up by the self mudstone during the late phase of transgression, as whenever there is no supply of sand, sand macroforms are not forming, we get deposition of pelagic and hemipelagic mud in the self area forming condensed sections which may continue into the overlying HST part as well, and that can act as a good seal rock. So, in this kind of scenario, those self macroforms can be an ideal area as they are having the good quality reservoir rock, and that is covered up by a good quality seal rock or trap rock. The problem that we can face, the risk that we can have associated with the exploration of the transgressive systems tract in terms of petroleum play or exploration of the petroleum reservoirs, that can come with respect to the identification of the reservoirs, because as you can see from this discussion that is going on from last 3 lectures, that the distribution pattern of the sediments, the distribution pattern of the individual sand and mud units, that significantly varies from area to area throughout the entire phase of transgression. So, we can get all these phases types, a lot of variation in terms of phases types. We may found phases types which are suitable, favorable for petroleum play, but how they are occurring, where they are occurring, and how they are distributed in the overall distribution pattern, overall depositional systems, that is one of the major factor that controls the quality of the reservoir systems, the reservoir qualities that can form during the transgressive systems tract. So, whenever we try to explore, when we try to demarcate this kind of reservoir rock bodies, what we have to do is we have to look for this kind of parameters. We have to look for the detailed architecture of individual sand bodies, individual mud dominated or fine grain dominated bodies within the entire TST for demarcation of this kind of reservoirs. So, overall we get a complete package during the transgressive systems tract, which is one of the advantage, which is one of the positive side in terms of formation of petroleum play or the formation of the petroleum systems within the transgressive systems tract. So, with respect to the overall distribution pattern, if I want to summarize now the occurrence of petroleum plays within the transgressive systems tract, what are the possibilities? In the fluvial part, in terms of sediment budget, we know there is a huge amount of sediment is being supplied, and those sediments, they are getting deposited in the river channels as channel fill deposits. They are aggregating very rapidly, but the aggregation pattern is more prominent in the overbank area than the channel fill part. So, as a result, we can get good sediment supply, good sediment budget, but in terms of reservoir quality, it is not that good, because the sand distribution, which is restricted within the channel fills only, they are laterally restricted, they are laterally truncated by the overbank deposits. So, in terms of reservoir quality, in terms of reservoir occurrences, the fluvial conditions are fair in terms of if I compare that with respect to the overall reservoir quality. And in terms of the source and sill material, commonly the channel fill deposits, they are underlain by channel fill deposits again, which have formed during the LST. Underlying sand, they cannot be that much good source material, but we can have good quality overbank deposits which can act as a good sill rock. So, we can have relatively poor source, but relatively fair sill rock in the fluvial part. In contrast to this, when we look into the coastal area, there we can get good quality sediment budget, because in the estuary area we know lot of sediments are coming in, lot of sediments are supplied by the river systems. In the shore area we get lot of sediment supply by the river system, lot of sediment is generated by wave and tidal ravinement processes. So, overall sediment budget is good, and if I compare that with respect to sand is to mud, again that is very good. In terms of the formation of reservoirs, since the supply of sand is high, so we can expect good quality reservoir to form in the coastal area, particularly in the estuary mouth area, particularly in the shore area when it is backstepping. We can also expect that in the shore face area. And in terms of the source rock, again the source rock, its quality is not very good because it is underlain by again the channel fill deposits which have formed during the LST phase. So, we cannot expect a good source rock, rather a poor quality source rock is expected. And on that, on the reservoir, if the transgression goes on, particularly during the late phase of transgression, if the self fines, they come over, or maybe the estuarine fine grained sediments which are forming in the central estuary part, they come over, they can act as good sill rock. So, the chances of getting a good sill rock, it is a bit moderate. So, we can call that one as a fair chance of getting a good sill rock. When you look into the shallow marine part, which comprises of some part of the shore as well as the entire shelf. So, there we get onlapping shore face and shelf deposits. So, in terms of sediment budget, definitely in the shore area, shore face area, the supply of sediment is high, but as we move into the shelf, particularly in the late phase of transgression, the supply of coarser materials are less. So, that affects the reservoir quality. So, the overall reservoir quality will be significantly low, particularly if I compare that with respect to the early phase of transgression to the late phase of transgression. Except the fact that during the late phase of transgression, we can find the self macroforms and they can act as good reservoir. In terms of the source and sill rock, in the underlying part, we can expect maybe some self deposits are there, the fine grained self deposits are present. So, they can act as a good source rock, as well as on top of the self macroforms or maybe on top of the shore face deposits which are onlapping, the onlapping self mud can come over and cover up, forming a condensation, and that can act as a good sill rock. And when we look into the deep water part, here again it varies significantly, particularly when we look into the early phase of transgression, it is a sand dominated part, sand dominated submarine fans are forming. So, that can act as a good reservoir. So, there the sediment budget is very high, significantly high. However, in terms of the supply of source rock and the sill rock, we can get deposition of pelagic and hemipelagic mud which can act as a good source rock. After the early phase of transgression, in the deeper marine part, we get deposition of mud flow. So, that can act as a very good sill rock, capping these sand reservoirs formed during the early phase of transgression, formed through these low density turbidity currents. So, the best TST reservoirs are commonly expected in the coastal settings, particularly in the estuarine part, in the deltaic part and in the beach sand. We can expect them in the self sand deposits, the self macroforms, and we can expect them in the deep water sandy turbidites during the early phase of transgression. So, overall this is the summarized part in terms of occurrence of the petroleum plays within the transgressive systems tract. When we look into the coal resources, when we try to understand the TST in terms of the coal exploration, this is the best part, because within the TST we can get the best coal deposits in any kind of basin. So, the time of the maximum amount of shoreline shift towards the land, the end of shoreline transgression, that marks the optimum condition, the best condition for peat accumulation. And when we are getting peat accumulation, that will subsequently lead to development of coal within the sedimentary succession. So, what kind of optimum condition we expect during the transgressive systems tract? Commonly during this phase, we expect a high accommodation is forming with respect to the sediment ratio. So, always we are getting some extra amount of water available, some extra amount of seawater is present with respect to the sediment supply. So, there is a flooded condition always, and that restricts the supply of sediments, particularly the coarser sediments. And this high accommodation also leads to relatively higher water table condition. So, which is one of the essential prerequisite for the formation of peat or coal. So, the balance between accommodation and sedimentation represents one of the fundamental prerequisite that optimizes the overall requirement in terms of the environmental conditions for significant accumulation of the peat or coal deposits. However, when we look into the condition with respect to the accommodation versus sedimentation, it is one of the prerequisite. There are other factors which need to be fulfilled. One of them is the groundwater, high groundwater level, which is also commonly fulfilled when you have the high accommodation condition. And along with that, we require vegetation growth. So, that vegetation growth is commonly controlled by, that is dependent on the climatic constraint. So, if that climatic factor is favorable and that is leading to significant amount of vegetation growth, particularly in the overbank areas, that can be supportive for the formation of good quality peat and coal deposits. Now, if we assume that all the conditions are favorable, all the conditions are fulfilled, during this TST we can expect the best developed coal seams, and commonly we expect them to associated with or get overlapped with the maximum flooding surface, because at the maximum flooding surface we get the maximum accommodation available. At the maximum flooding surface we get the finest grain size available. At the maximum flooding surface we get the least amount of coarser fractions supplied into the system. So, commonly the thickest and the best quality coal seams are expected to associated with the maximum flooding surface, that is the end phase of the transgressive systems tract. The source areas which are significantly denuded now, significantly lowered now, they commonly supply less sediment with respect to the earlier phases of base level rise, for example during the low stand normal degradation or maybe during the early phase of transgression. So, that denudation in the source area and less supply of the sediments is a helpful parameter for the accumulation of peat. So, in terms of coal occurrences, we can expect the best quality coal deposits near to the end of the transgressive phase, commonly associated with the maximum flooding surface. Now, if we look into the placer deposits, so commonly we can expect some placer deposits to form associated with the transgressive ravinement surface. So, the transgressive ravinement surface, commonly the wave ravinement surfaces, they are associated with some scouring and reworking in the near shore environments, and they can be associated with lag deposits, commonly we call them as the transgressive lag deposits, and associated with these lag deposits we can get economically significant placer deposits. So, the overall geographic distribution of the transgressive placers, they are commonly controlled by the location of the paleo shorelines. So, with respect to the shoreline, along the dip oriented transect, we can expect the onset and end of the transgressive stages having different extent of erosion with respect to formation of the tidal refinement surface or wave refinement surface. And that extent of erosion going on throughout the transgressive phase controls the distribution of these placer deposits, which will again vary with respect to the position of the paleo shoreline. So, as we have discussed in case of the falling stage systems tract, as we have discussed in case of subaerial unconformity and RSME surface, where we have seen that the distribution of the placer deposits are commonly associated with or commonly controlled by the paleo shoreline, which acts as the central element in the exploration for placer deposits. In case of TST, it is exactly the same again. Here also we have to look for the paleo shoreline position, because with respect to the paleo shoreline position, the wave refinement process and tidal refinement processes will vary, and that will lead to different types of distribution of the placer deposits in different parts of the basin. So, depending on where the maximum transgressive shoreline is located with respect to the basin margin, the distribution pattern of the transgressive placers will vary. So, if we try to go for exploration of placer deposits solely based on mapping of the basin margin unconformities, there are chances that we may miss some of the placer deposits. So, again, as I told you during our class on the FSST part, FSST falling stage system struct deposits, there also we discussed about this particular aspect. So, that same point comes over here again, that whenever we have to go for exploration for placer deposits, we have to consider the paleo shoreline, because that is the key element in terms of distribution of the placer deposits. So, with this we come to the end of this particular session that we are going through for last 4 lectures on different aspects of the transgressive systems tract, and we have discussed about the distribution pattern of the different depositional systems, the processes and the products at different phases of the transgressive condition across the entire basin tract, starting from the fluvial part to the coastal area to the salomarine part and in the deep basinal part. And also we have tried to understand with respect to these processes and products, what are the potential hydrocarbon occurrences, coal occurrences and placer deposits within the transgressive systems tract. So, these are some of the references that you can go through for further reading. Thank you everyone.